Hello, everyone. Welcome to our presentation today on revolutionizing industrial control. So today we're going to show off, really to me, what is this fascinating intersection between PLCs, which can control industrial machinery, gather data from that machinery, and machine learning, which can interpret said data and generate inferences based on that data, frankly, in milliseconds. Now, building off of that, we're going to see how adding wireless connectivity gives you that secure cloud integration so that you can easily relay that data, those ML inferences, and to generate alerts, create cloud dashboards that are really engaging experiences for your end users. Now, to accomplish everything I just stated is going to rely on three complementary companies that are either household names or I like to think becoming household names. Now, if you can't tell yet, I'm personally pretty excited about this collaboration as I think you'll see some real strengths from each company kind of play out today. Now, before we really kick things off, if you have any questions during our presentation today, please ask those in the Q&A panel. You can ask them in the chat panel, but we might miss them because there's probably going to be a lot of activity there. We're going to actively answer as many questions as we possibly can during the presentation. If we have time at the end, we will do more of a public Q&A as well. Now, a question we always get is this being recorded? And the answer is, of course, yes, it is being recorded. It will be available on the Blues YouTube channel at this URL. While you're there, I, of course, recommend subscribing to the channel so you're the first to see all this fantastic video content. Now, the last of our logistics includes intros for the amazing speakers you're going to see today, starting with Francesca Gentile, who's a product manager at Arduino. Also, from Edge Impulse, we have Owen Jordan and David Tischler. And lastly, we have TJ Van Tol and myself from Blues. So it is a great lineup. I think you're really going to enjoy what we have to show you today. Now, I'm going to take a minute to set the stage here a bit. So everything we build today is based around the Arduino Opta PLC. If you're not familiar with PLCs, the acronym stands for Programmable Logic Controller. Now, at a high level, it's basically an industrial computer designed for automation of manufacturing processes or machinery, really any activity that requires high reliability and real-time operation. So PLCs are widely used in industries like automotive, oil and gas, packaging, really anywhere you need to control machinery by receiving inputs, processing those inputs, and then controlling devices like motors, valves, or lights. Now, inside the Opta is a really beefy STM32H7 microcontroller, so it can pretty much handle anything and everything that you throw at it. Now, when you talk about disruptors in the PLC space, well, the Opta may take the cake. It does cost a fraction of its PLC competitors, and I honestly saw this firsthand, how excited everybody is about this product, as I was able to attend an event called Automate in Chicago, where Blues joined Arduino in their booth and the Opta was featured. It was really something else to see the excitement around this. Now, I don't want to go too deeply into the Opta, as Francesca is going to provide more context on that in a bit, but the Opta does provide plenty of I/O, access to relays, and today we're gonna want to connect and control something, right? So take an industrial motor, for instance. Now, using the Opta, we can measure things like temperature, sound, maybe vibration patterns, everything that can provide us information about the state of this or really any connected machine. Now, using a machine learning model built with Edge Impulse, we can input that data and generate live inferences that can tell us that maybe the motor needs to be shut down or will fail soon or is operating out of spec. And these are fantastic, invaluable insights. But then we need to communicate those insights, right? And that's where the Blues and the wireless for PLC expansion comes into play. This product literally snaps onto an Opta and provides turnkey cellular data syncing with any cloud. So you can use this to build out things like SMS alerting and live dashboards, and it can also provide bidirectional communication capabilities. Now, that is a lot to process, I agree. So let's start bringing in some experts here and begin with a high-level demonstration with Owen and TJ. Then we're going to give all the parties here a chance to kind of dive into their specific part of the collaboration. So I will stop sharing if, Owen, you want to take over.
Some great animations, Rob. I don't know how much time you spent making
Too
the
much.
two pieces come together, but
Yeah.
I think it was totally worth it.
Yeah, absolutely.
So, uh, thanks, Rob. I'm just going to start by showing some of the data that we have
here. So let me just share my screen. So I think if we get straight into what we're trying to detect first, I'm just going to share my full screen here. I'll bring up the data that I have coming from the industrial motor that I have connected just below here. It looks something like what you will have seen on our booths if you've seen this DC motor demo. So what we're doing here, instead of collecting data from the accelerometer, we're collecting power data, and we're doing that. I'm actually following one of our expert network demo projects that David and I work with. So it's from our community. Someone obviously is more capable in motor control and industrial automation. I'm just playing the position of a industrial automation engineer here today. But so what we're doing is we're gathering the power data from a motor. So this is data that we've uploaded to Edge Impulse. And we're not going to get into too much depth on this now, just give a brief overview because we want to show what the value is here. And the value is what we're trying to demonstrate, how to detect an anomaly in a condition that we know is nominal or normal. So this is a normal working motor that we've collected over a range of speeds. So we can set the demanded speed, record the data. So we've got a lot of this data that's streaming in from our connected motor. So in an industrial automation scenario, we may have PLCs that are controlling motors that are dumping out data. They may not be connected to anywhere, or the insights may not be actioned locally. That's where Edge Impulse comes in. We can make these decisions at the edge within 20 milliseconds. So this is the data that's coming in that we've got labeled for our nominal condition. And it's a very intuitive, user-friendly interface for building with. And that's not to say that it's limited, because behind each of these blocks, we've got dedicated teams like our digital signal processing team and engineers who are familiar with PLCs will be able to go into depth with their own digital signal processing algorithms. You can work and integrate with your ML team as well. So each of these blocks, a regression block here, for example, and the star of the show today, which is the Gaussian mixed model anomaly detection block. I'm going to show how the data will be displayed then. So Gaussian mixed model is a clustering algorithm, and you can apply clusters to points of your data, and anything that occurs outside of this data can then be detected as an anomaly. And we can do something with that score programmatically, like shutting off our motor. And you can do that within 19 milliseconds here, and it only takes 3K of RAM. So once we get to the end of building our impulse, which is our ML architecture, we can deploy it as a Arduino library. And anyone who's familiar with working with Blues or Arduino will know how easy it is to import a library and start to work with it. So that's where we get to the code. And right at the top, you can see here, this is our note card, which is our Blues component, the library that's imported. We've got our Edge Impulse Opta motor anomaly detection. And we can just see that we've got the demanded score, the demanded power that we're trying to set our motor to, and the actual power. And right now, it's set to 0 because I had some problems with my motor because it was overheating because the controller that I was using to convert from 230 to 24 volts was getting hot, and it broke the bracket that the motor was mounted to. So I'm not going to electrocute myself here in the name of the demo, but I can show you the video of it operating here. But yeah, so you can see the output here. So if you want to jump in at any point, TJ, to talk us
Yeah.
through the
Do you want to bring up the dashboard side of this as well? Because
oh, the dashboard, of course.
the other cool thing about this demo is that we're sending all the data up to the cloud to an Arduino cloud dashboard that we can use to both monitor and control this project. So you'll see that the anomaly scores, which are the scores that are actually coming from the inferencing model, are kind of high because the motor kind of overheated a little bit on us, but the data is flowing through pretty consistently. And that all this data is actually flowing through over a cellular connection. And it's because of the wireless for PLC. That's the expansion module that we make at Blues. It was the blue box that came in Rob's slide that's actually providing the connectivity here. And the wireless for PLC, it enables connectivity over cellular or Wi-Fi. So in the case of our demo, all of this data is going over cellular that's driving this dashboard. But the fact that you can do both opens up some really cool options. Like you can send all of your data over Wi-Fi by default, but if your Wi-Fi network goes down, a lot of these industrial Wi-Fi situations are questionable at best. If it goes down, you have a backup. If the device moves for whatever reason, if you're in one of those situations, you have a cellular backup there as well. But the powerful thing about the wireless for PLC and just Blues in general is how seamless and easy the connectivity is to implement. So if you look through this firmware, you won't see any code related to cellular. There's nothing about a SIM card. There's no modem code. There's no AT commands. Everything is being coded in a fairly generic way. So yeah, in the things property.h file, you'll see there's one variable defined for everything that is represented in the dashboard, or really every piece of data that we want to work with. So we can operate on the LED, the relay that controls the motor. And then we also have some values for an anomaly score and an anomaly threshold. And then that chunk of code at the bottom is configuring how the interaction with Arduino Cloud should happen. Should the data be read-only or read-write? So we have the LED and the relay is read-write because from the cloud, you might want to use your dashboard to be able to turn off lights on a device or to be able to remotely shut down the motor. If you're seeing some signals that look bad, maybe I want to pop in and turn that thing off without having to physically visit the device. And that's the sort of thing this makes possible. Or you might have data that you only want to read. So if you look at line 34, the anomaly score, we're just publishing that every 5 seconds. So the model is running inferences on the device constantly through the firmware running on the Opta. But then every 5 seconds, it's saying, let me take that latest value and just publish it kind of in the background using Blues, push it up to the dashboard so that I have that graph that's showing the latest value that appears here. And really at a high level, that's kind of what we're trying to show of how these pieces of technology fit together. So the Opta is kind of mission control of this situation. It has the ability to control this industrial equipment. It has the ability to run these models. Edge Impulse is giving you the tools to build those models that run on the edge. So you can take these models and you could shut off the motor yourself because you're detecting that in 19 milliseconds or whatever Owen says really, really quickly. And then Blues is providing the connectivity part of things. So it's what enabling us to drive this dashboard to both see data coming out of it and also to control. So it's just giving you a lot of tools in the toolbox for building this sort of industrial system. And I think that's high level, but I think we're going to dive in more. So I think, Rob, we're going to go to Francesca next for the Opta. Is that, do I have my order right?
Yeah, exactly. So we want to take some time to kind of dive into the individual components a little bit more. And what better way than to have the literal experts in these fields? So Francesca, if you want to dive into the Opta a bit, that'd be fantastic.
Absolutely. So first of all, thank you so much. There couldn't have been any better presentation of Opta really working into a real environment and connected to these devices and also running an AI model. So basically what I'm going to do today is giving a little glance of the reason why we have built Opta and basically the main features that are somehow enabling all of these great applications that of which you showed just now an example. So basically, Opta has been conceived to work in the industry, first of all. So something really important is, of course, to comply with the industry standards. So Opta is, of course, made with industrial grade components, respecting the industrial certifications like UL, CUL-US, and FCC. And it has been created in order to satisfy the needs of the PLCs, micro PLCs industry, but with something more. So what we can see here is a list of the variants that we have, and all of them are connected. And this is the first key point. So we can provide connectivity to the network thanks to the Ethernet port on board. But we also have a couple of other variants. One has also an RS485 terminal rack to enable Modbus RTU. And we have a third one, which enables connectivity via Wi-Fi and Bluetooth And this does not only mean connectivity to the network, but it also means that we are capable of acquiring signals from devices that are acting as sensors. And this is very relevant also in the condition monitoring and predictive maintenance application, for which we just saw an example. Another critical point for us is to ensure the data security. So we will see later on that we basically are leveraging data security in many ways. We have said already that we have a very powerful brain, and thanks to the STM32H7 microcontroller that we have on board, we are really capable to get the models and for which we just saw an example. And so we can really run AI on the edge. And for sure, we are taking the benefit of the Arduino ecosystem. So we just saw the simplicity of programming the device and interacting with other, let's say, bricks of an ecosystem in order to realize any of the application that we need. Last but not least, we have just saw the Arduino Cloud implementation. So just to go a bit deeper into the topics, the Ethernet port, which is available on all the versions, can support not only the TCP/IP communication, but also field bus. So TCP/IP can be used, and this is one of the mainly used standard communication protocols in the industry. We have also, as said, the possibility to communicate through Modbus RTU half duplex, and also eventually to create other custom protocols leveraging this option. And then we said the wireless connectivity. What we really want to stress is the concept related to the security. This is something that we, but also Blues Wireless, is really considering as a milestone of their development, because we really need to give a device that can assure the data integrity, and hence we have conceived the product with a component on the hardware, which is a secure element that can, let's say, store keys, can manage certificates, and so can really enable a secure communication. This is also, of course, something that we care of on the Arduino Cloud side, on which we have the multiple factor authentication. We can enable the secure firmware update of the devices to keep them really aligned with all the security rules and regulations that are also, let's say, coming more and more as restrictive needs. We spoke about the STM32H7, and frankly, I don't have much more to say, because you saw already how good is an implementation leveraging its performances. And on the other side, let's just give a quick glance at the, let's say, usability of Opta, on which we really see that we have just used the same very, very simple concepts that made the Arduino story so successful. So just to give you an example, you can just switch a relay and close a relay by using just a digital write command. So very easy and straightforward. On top of this is a professional product. So there are several libraries that are supported in order to enable industry communication protocols, such as, for example, Modbus RTU. Last but not least, one other topic is to be very inclusive. This is another key factor that we have. So we have also decided to implement an IDE dedicated to the standard IEC 61131 programming languages. So just to give you an example, the ladder logic, structured text, so both visual and coding languages that are really, really common in this industry. And we have provided a very professional interface, which also has lots of debugging ways to check the code. It has an oscilloscope, just to give you an idea. It has a watch window to check the status of the variables. The Arduino Cloud, just a few words about the Arduino Cloud potential. Through Arduino Cloud, basically, the users have the possibility to write code without having anything installed, and also to benefit from an approach that is basically a low-code approach. So when sketching on the Arduino Cloud and when creating the variables, we can really enable let's say, self-written part of the sketch, which is related to the characteristics of the variables that we are using. We have also released recently some new features like the collaborative sketching, which is a possibility for different programmers to work contemporarily on the same sketch. We have the possibility to create custom templates that can be used by third parties that only basically need to get the benefit of a pre-configured program with its dashboard without having such in-depth knowledge about the Arduino programming. And of course, we said already about the over-the-air updates and the possibility to enable machine learning tools. So this is a synthesis of what we are giving with Opta. On top of this, we also, let's say, some applications in which we really see Opta. So we have an industrial machine here, for example, presented where we are leveraging AI models in order to do predictive maintenance, which is actually the case that we were presenting before. We also have the possibility to do almost the same with models for energy consumption, or just eventually to connect the device in order to actuate devices remotely. And what I wanted to say before is that we also have an ecosystem of expansions. Some of them, which are the ones that you see on the screen, are developed by Arduino. Here we have a set of 3 I/O expansions. The first 2 are the ones that we call digital. They start with a D in their name, and they have both of the 16 inputs that are programmable in the same way as Opta, and 8 relays. In the first case, the one ending with E, as electromechanical relays, so the same type of the main Opta controller, while the other one has solid-state relays. So we are covering different scenarios and applications. On the right side, you also see an analog expansion, which basically enables to manage analog signals. And it has 8 channels that can be configured as inputs or outputs, in voltage or in current. And as input, we also support temperature readings through RTD. On top of this, we also offer 4 outputs for PWM outputs in order to control devices that need analog signals to operate. Just a very quick summary here. Also, in this case, we can program the system with both the methods, so standard PLC coding or Arduino. And so where we are today is basically in a situation in which Opta is expanding its operating field thanks to integrations related to new libraries to support different protocols, thanks to its own expansions. But today we're together with Blues because basically their expansion is enabling new models. We just said, so Rob just covered one of the cases, which is a backup connectivity, but we also have several others, which are the really impossibility to connect with any other method rather than cellular connectivity, for example. And so some of the use cases together with the expansions and that can also benefit from the addition of a Blues wireless expansion are, for example, multi-phased industrial processes plus quality control, in which we might really need to have alerts that are coming in real time independently on the connectivity that we have. So we really want to have a quick glance of what is happening in real time. For example, efficient facility management. We have something that is located in a remote place where we do not have an easy access to Wi-Fi and Ethernet connectivity. Also over there, we can surely benefit of the cellular connectivity provided by the Blues wireless expansion. Here we have just a quick case related to an example of quick fast switching production where we have used a solid state relay expansion and where we are effectively measuring several conditions on the edge, basically. And also over here, we have represented one of our sensors that is the NICLA but of course, any other sensor can be used to collect data from the field and also to elaborate them thanks to, for example, the edge impulse models. And zero-touch manufacturing. Also, this is an applicable case for Opta, where, for example, we want to really monitor the operations in real time and take actions on the edge based on the data that we are reading from the system. Similar case is also precision control on the production floor that also would need analog signals processing. Here there is a case of a production test bench as an example. And again, also here we are leveraging the benefits of having a connected system and clear dashboards in order to show operators what is happening on the edge. So this was my wrap. Of course, I would be really happy if there are questions to answer. And so back to you, Rob.
Great, thanks, Francesca. I knew this would happen when Francesca showed off the PLC IDE. Somebody would ask this question about whether or not you can program the Blues expansion with the PLC IDE. And TJ, I'm going to put you on the spot here for a second because I believe you or Owen came out with a solution. Is that right? Or am I off base here?
Yeah, Owen got this working, I believe.
Yeah, so this was really cool actually, and this was the subject of I published a blog on our blog earlier in the month, just to kind of discuss why we think this is interesting as a piece of hardware and how you would integrate it with ladder logic. So it's pretty interesting that you can partition a portion of the Opta. So there's two cores in the Opta. There's the H7, which is like a similar core that's in the Portenta, if anyone's used that, and then there's the M4. And at Edge Impulse, we can run our anomaly detection algorithm on as little as an M0. So you don't really need a lot of space to be partitioned to run your machine learning algorithm. But it's really unique that you can run this C++ application on a portion of the Opta, and then you can share these global variables with your ladder logic. So you can have your ladder logic if greater than or equal to threshold, and that threshold could be something that we share through the Blues wireless node hub, and it can adjust through our two-way interaction on our dashboard. I know TJ is going to go into that a bit more, but yeah, the portion that you can absolutely work with it with your PLC ladder logic IDE. I put a very crude demonstration in the blog, so if you want to check it out on our docs, you'll be able to see that. And I'm going to follow it up with the code that we're demoing today as well. And
Sally
yeah,
posted a link to the blog post in the chat as well, so if anybody wants to follow up on that. But I want to give David. Oh, sorry. Go ahead.
Oh, sorry, Dave. Sorry. Yeah, of course.
Yeah, go ahead.
All right. Can you see my screen? Has it come through?
Yeah, looks good.
Okay. Well, first things first, I need to apologize. I'm having a browser window fight over here. So you have the the address bar and the tab at the top. I was not as successful as Rob and Francesca in getting my slides into a full screen format. But I'm laughing because it's only 8:30 in the morning here. I was looking at the various locations around the world that people are joining from. And I think most folks are, middle of the day, evening, but I'm here in Phoenix and I'm in PST, and I was looking to see if anybody was further beyond. I think it's the earliest. I think I have the earliest time zone here. So you get the address bar. Um, but I'll take us one level higher into the machine learning portion of this journey here. And I'll speak to Edge Impulse. Now, Owen stole a little bit of my thunder. Perhaps I should have gone after Rob, but he showed off some of what I have in my slides here already. So for those of you who are not familiar with Edge Impulse, or what we are bringing to the table here in this conversation, Edge Impulse is the Edge AI platform. And what that means is we are building a SaaS-based, a cloud-based utility and system to allow ML teams to run their AI on any edge hardware with ease and speed. And Owen actually touched on that earlier as well, with some of the inferencing being done on the device, on the Opta, at the edge, in order to, whether that is turn off a motor nearly instantly, or Francesca had amazing slides there with industrial automation machinery, test bench equipment. I saw a packaging and cartoning machine in there. Oh, and I saw you have that little motor there, but that packaging machine looked pretty nice. I think you're going to need to get one of those. From the higher level perspective of what type of data we can ingest into Edge Impulse in order to build a machine learning model, we can handle sensor data, audio data, or image data. In the sensor data world, you're talking mostly about pattern recognition. That could be gestures if you're using an IMU. That could be motion detection. Anomaly detection here is kind of what we're talking about in the motor and PLC world here, where you're looking for increases in voltage or current or other variables. If you're looking at some of the other equipment that Francesca showed off, that could be pressure, that could be temperature, that could be what else was in there? I'm sure that the packaging machine has actuators and other moving parts that would be included in the, literally the folding of the boxes. I think might have been a coffee roaster in there. So, humidity, pressure, things like that would all be very valuable inputs. Audio data. Okay, now in the audio use case, you've got wake word, keyword spotting, so we can build models that will allow you to have custom wake word detection, listening to these sounds in an environment, things that may sound incorrect. Classification, you got certain noises that a machine should make, or maybe it should not make. Image data, that's a traditional use case. You're probably familiar with those, and that's your image classification or object detection. In the object detection scenario, you can also do anomaly detection. So in manufacturing scenarios, if you're building parts, you're building PCBs, you're building industrial fittings, valves, whatever it is that you manufacture and produce, if you have a quantity of known good samples and you collect enough pictures of what a good, pristine object it is that you create and build and manufacture, but all of a sudden, a part goes by on your assembly line that doesn't quite look right, well, we can build models that will detect for that. Of course, using something like an Opta, you could then do automatic sorting and binning as items are coming down a manufacturing line. Trigger servos, motors to reroute work or products through another workflow or work stream then. And we're, of course, focused on the Opta today, but we do support almost any sensor, any data, or any use case. all the way from the ultra low power, like Owen mentioned, the Cortex M0s of the world, up into the high-end MCUs, like the STM32H7 in the Opta, where you've got M7, plenty of memory, plenty of processing power, 2 cores, I believe, actually, in the STM32. And there's other manufacturers, SoC parts and microcontroller parts that we support as well. NPUs, where you have custom silicon for AI acceleration. MPUs, which are combinations of the two, typically an MCU plus CPU or an MCU plus NPU, and GPUs, of course, as well. So we can support things like NVIDIA Jetson devices that have integrated GPU cores and will run the model on the GPU cores in order to take advantage of those for, acceleration. And one of the things that we didn't really talk about in this particular demo that TJ and Owen showed earlier, but the ML ops loop is a critical component when you're talking about edge AI. And this is something I've found challenging when you go and you want to build an AI model. Okay, you start off by collecting data. That's taking pictures of your product. That may be collecting audio samples. If it's wake word or keyword spotting, that's repeating that keyword 100 times, 1,000 times to build your model. You go through our workflow, and I'll show that off in a moment, to design your what we call impulse, and that's essentially becomes your algorithm, your model that you're going to deploy. There's a testing framework also in Edge Impulse to go through some set-aside data after your model's been built that'll allow you to validate your performance and figure out just exactly how well your model's working. Deployment, of course, is optimizing for the chosen edge hardware, like I already kind of showed off there in the previous slide. And then you come away with a model and you put it out in the real world. And what if it doesn't work too well? Because the conditions that existed in your lab or on your desk when you built your model may not match what happens out in the real world, where there's extra noise, lighting conditions change, other movements that you may not have accounted for or compensated for, noise in your data. And so what you want to be able to do is actually bring data from the field back into your ML ops loop, retrain your model, now compensating and accommodating these other conditions, retrain, and come away with a smarter or better model that's more accurate, that can filter through and identify when something is actually just noise and give you better results out in the field. So going through the 4 major steps, we talked about collecting data. You definitely are going to need to collect some data. Owen showed off data he collected from the motor, and I have a slide for that in just a moment. But to collect your data, you can attach devices directly to your laptop, or you could, if you already have a data set that exists in S3 or Google Cloud, simply bring that into Edge Impulse. And you can sort of go through and inspect and visualize what your data looks like in each individual sample. Again, you can collect audio, sensor, or image data. Add your labels, bounding boxes if it's object detection, and move your items between your training and your testing data sets. Going through the actual creation of the ML model is simple, it's intuitive. You go through what we call the creation of an impulse. You select your processing and learning blocks. There are expert modes for those who bring their own keras, or you can even bring in custom blocks to do pre-processing if necessary. But there's multiple frameworks in here, YOLO, MobileNet, Tau, and more. And there's all available via API as well. At the end of the process, you will come away, though, with the built model. After you have that model, like I said earlier, you want to be able to test that model. And so during that data collection phase, you set aside a portion of your data that never went into the training. So this data is unseen by the model, and it'll allow you to then evaluate your results. Test your development and your data in the real world, because you can collect straight from the device. You could place it over into Omniverse or other Gen AI utilities. You get clustering visual representations to sort of pick apart what worked well and what did not work well. And then finally is the deployment. We talked about this already as well. There are lots of ways to deploy. That could be hardware target driven. That could be Arduino or C++ libraries. Owen and TJ showed off, as an Arduino library, which is what we'll focus on here. And then there's CLI and flashing utilities to get your models onto those devices. We've seen the Opta already, and we kind of took a look at this earlier when Owen showed off, but this is a screenshot from his data collection on that O-drive motor that he was using. And so what he's doing is capturing the, it looks like this was a 5,000 millisecond, so 5-second sample of the motor power increasing over time. And, you can inspect any of these samples that he collected. And I don't know if that data set was public or not, but if so, we could always make it public. And anyone viewing can go and have a look at the true data that you collected from that exact specific motor. Here he built his impulse. And like he showed earlier, he's doing regression on the data set, but also added the anomaly detection block. And that anomaly detection block, you can see the clustering is actually very tight and very linear from the motor power that he captured. So in this particular case, it would be pretty easy to identify any outliers. But over in visual image classification, image or object detection scenarios, you see much more scattered clustering. I probably should have grabbed a screenshot of that as well, just as a compare and contrast example. But this one here, you can see how that GMM closely hugs the that linear line there. And then finally, he showed off the deployment already. We are going with an Arduino library in this case, but of course, lots of other hardware is definitely supported as well. And that actually does it for me. I think if I remember all the way back to the beginning, Rob, you were up once again, or were we going to TJ for
I am a
special demo?
TJ and I both, and we do have a special demo for TJ.
Oh boy, that's exciting. Let me stop sharing.
Yeah.
Okay.
Exactly.
All right,
So,
everybody say your prayers.
Yeah, as I'm trying to share my screen here, as I'll go off script for a second, because as I'm watching what Francesca is presenting, what David's presenting, I'm realizing like what kind of binds the three companies together. I'm going to try and do two things at once. It makes me kind of realize and appreciate how every company here, Blues, Arduino, and Edge Impulse, are really solving really hard problems and doing it in a really easy to way method, but without reducing developer control. And I think that's a really interesting kind of intersection of like solving that hard problem, but not not eliminating developer control, which I think is really important. Anyway, I just thought that was kind of a key takeaway here. But anyway, I have the pleasure of introducing you all to what we're up to here at Blues. And while I'm sure you already got a sense of this, if I can really oversimplify what Blues is about, we're here to provide hardware and services that back up this message of making wireless connectivity easier for developers, and frankly, more affordable. And I'd argue that one of the reasons we exist is that implementing wireless connectivity, especially on the cellular side, is not a trivial process. In the traditional model of adding cellular capabilities, you're doing what? You're sourcing a modem, you're sourcing a SIM, you're paying a monthly fee for that SIM, you're spinning a custom PCB, managing battery life, writing AT commands. You are managing tower handoffs, rotating keys, generating certificates, writing cloud functions. And this is all just to get your data to some cloud. Now with Blues, you can think of Blues more of like IoT infrastructure, like Visa or MasterCard are to the credit card world. Blues really provides the infrastructure for the wireless IoT. So we build that secure private infrastructure that provides that like turnkey bidirectional syncing of data between your cloud and your device. Not to mention low power management, tower handoff, cloud integrations, no monthly SIM fees, and so on. So our core hardware product is the note card. This one in particular that you see here is a dual cellular and Wi-Fi device. It is the one that is inside our wireless for PLC product. It does come prepaid with 500 megabytes of data, 10 years of global service. That's all baked into the cost of the device. So when you buy a note card or when you buy the wireless for PLC, you're not paying subscription fees or monthly SIM or data fees. But really, our hardware is only half the story. The other half is our cloud service we call NoteHub. And the two work together to form what's effectively a device to cloud data pump. Now, you've already seen today how the STM32H7 in the Opta can process data and use the note card to deliver that data securely over cellular to NoteHub. And NoteHub will then route that data to Arduino Cloud or frankly, wherever it needs to go. So to be clear, NoteHub is a cloud service, but we're not trying to create a platform that locks you in, right? We exist primarily to help you connect to your platform. And yes, there are other note card options beyond that Cell plus Wi-Fi note card. It all depends on what radio you want to leverage. The good news is these are all swappable, both in terms of the physical connector and the APIs that we provide. So there are a range of cellular-only note cards that provide Cat1, Cat1 Biz, LTE-M, NB-IoT. There's Wi-Fi only note cards. There are LoRa only note cards. There are, again, a set of the aforementioned dual cellular and Wi-Fi note cards. We also have a satellite add-on for the note card called StarNote. StarNote allows for fallback satellite communications in supported regions. So we have a lot of good coverage here. Now, finally, we get kind of the heart of the Blues part of the webinar today, and that is our wireless for PLC expansion. I wanted to address why it exists, and maybe you've read through the lines today a bit, but there are significant reasons why we expect companies to adopt this product. And frankly, it starts with security. It doesn't get much more secure than a communication device that is separate from your local network infrastructure, connects through private VPN tunnels, does not have a public IP address, also lets you encrypt your payload. That's all what Note Card brings out of the box. Likewise, oftentimes local IT does not want to add more devices via Ethernet or Wi-Fi, whether it's for provisioning reasons or just general management reasons. And also our cloud integrations are very simple. They're turnkey. Do you want to work with the Arduino Cloud? That's great. You saw that today. Want to send data to AWS or Azure or GCP? That's fine as well. So that's my very quick Blues spiel. And for our last segment here today, I'm going to pass it over to TJ for his show.
Yeah, and I'm going to start by just showing off the hardware I have here because I'm going to be using it for this last demo. So over here, I've got my Opta and then my wireless for PLC over here. What Francesca said earlier is indeed correct. These things slot together. There's a little aux connector between the two, and they fit together like Lego pieces. It's actually quite satisfying to connect the two together. Now, I don't have anything fancy hooked up here. I don't have any industrial motors. Rob doesn't like to improve my expense reports for fancy equipment. But I am gathering some basic data because I want to show off one last feature of the wireless for PLC that we haven't talked about quite yet. So this guy has a lithium-ion capacitor in it that provides some battery backup for a very specific reason. One thing you might want to know if you have one of these PLC running on something important is you might want to know when the power goes out, because that can be potentially dangerous or at the very least cost you money because one of your facilities is down and you might need to get to it right away. So what having the wireless for PLC lets you do is to be able to operate independently. And again, because it can talk over cellular, it doesn't need to worry about, hey, the Wi-Fi is down because the power is also down at the facility, and can independently send out an alert. So to show that, I'm going to now bring up my screen and give a little demo of this. So we will bring that up. And what you are looking at now is NoteHub, which is the cloud service that all note cards know how to talk to out of the box. You can see I have a device connected here. This is just the one on my desk. And if I go into the events view, you can see all the data that's streaming out of it. And I just have some very simple temperature data. Like every half hour, I'm publishing the temperature out. And I'm connecting, in my case, to Arduino Cloud. That's the same thing that you saw the demo at the top of this webinar possible. I do want to quickly show, just because Rob mentioned it, that with the Note Card and NoteHub, you have the ability to connect to a number of different services. So I have Arduino Cloud enabled for sending my data there, for building dashboards there, but I could send my data over HTTP, MQTT. The big clouds are in here. There's some alerting systems and some IoT platforms in this list as well. What you can also do in NoteHub, and the key to this demo, is that we also have some built-in behavior for sending types of alerts. Now, there are a number of things you might want to alert based off of. Maybe if your device just goes off the grid, you might want to know about that. You might want to notify if you're getting anomalous data. So you've got your model, your Edge Impulse model running, and suddenly you get an outlier. Well, maybe you want to get a text or an email about that so that you have somebody look into that and see what's up with the motor. Now, in my case, I just have a very simple power outage monitor. And the way you configure these, I'm not going to go into detail on every field, but basically you just say, what type of data am I looking for? I happen to know that the note card publishes what we call a health.qo underscore health.qo event when it detects this power outage scenario. And then down here, I say that I want to receive an email when this occurs. So I'm going to go ahead and kill power to my device. And it takes a few seconds. We'll see how lucky we are today. Actually, that was instantaneous. That's the current timestamp. So I got that the USB power is off. And so what that'll do is, since this is an underscore health.qo message, this will send me an email. And actually, the email servers might be the bigger cog in the system to see how long I got an email. The email is going to look like this. So I have one from the previous time when I was testing this morning, where I just get an alert that the power is out, and it's going to tell me this is the voltage on the lick, and it has links to details if I want to see more information, like an exact timestamp and such. And I'll see if I get my more recent email, but hopefully this gives you a sense of just the sort of configurability you have available to you. So you can set up alerts for power outage, for anomalous values. You can have them go to email. You can have them go to SMS. You can have them ping a Slack channel. Really, what we're trying to offer at Blues is flexibility for really everything you see, for connectivity, whether it's cellular, whether it's Wi-Fi, for where you want your data to go to different services. We're just trying to give developers options to make all of this sort of stuff possible. And I think that's what I got for us today. Hopefully that's pretty cool. I like the lick. I think is pretty slick. It's a cool piece of technology just to you can, even if you're not into industrial, maybe you watching this, you don't have industrial equipment that you maintain, but you have some place in your house, you just want to get notified when your power goes out. Like, having a note card for that is kind of cool, to just get a text message like, hey, I just lost power. Maybe I want to look into that or call somebody.
Yeah, that's great. Thanks, TJ.
That's cool.
Thanks, everybody. I know we have a couple minutes here that we can get it in some more public Q&A. Attendees, if you have any questions, now's a great time to get them in, and we can kind of go through and answer anything. I know we covered a lot of material and a lot of complicated topics here. So if you want to dive into anything, please let us know. Panelists, I don't know if any question earlier on kind of stood out for you, if you want to repeat anything, or have any final thoughts. Not to put anybody on the spot.
Yeah, I guess just wondering if anybody else has experience with PLCs. Do they, had they imagined a scenario of running a dual core PLC, or have they experienced any other ones in the industry? Or how are they tackling these kinds of problems right now? Be very interesting to hear some feedback from people with ladder logic experience or PLC experience. I know we had a couple of questions there, but just to get some insights into how people see this functioning for them.
Yeah, PLCs are generally pretty new to me as well, so definitely curious to learn more.
I think,
Um,
yeah, like
I did,
I come from wireless electronics as well, and it just wasn't covered in courses that I did. Industrial automation is kind of a specialty of itself, and it's just I know there's industrial IoT, so just like what are people's real world experiences with getting data off these devices, how they normally do it, or how yeah, anything that they want to jump back with here or hit us up with on the forum, it'd be really interesting to hear some um, of their experience.
Yeah, in my experience, I've heard a little bit of everything in my experience in this space. I think everybody's got some like bespoke things, some of which were like done years or decades ago that they want to get data off of. A lot of people trying to modernize in this space. So I like the theme that Rob said is like really the organizing theme behind all of this is configurability, because we kind of all recognize that everybody's got to work around some requirements. Very few people are stepping into this space with total control over everything. So we're trying to help you out the best we can.
yeah, absolutely. I saw a couple questions pop in here about the note card in particular. Somebody's asking about a 5G private model network. Is that in the cards? I mean, anything and everything is possible. I'd say from the Blues perspective, we have a pretty diverse array of radio options with our note cards. There's definitely nothing to announce today in terms of 5G support, but next year, who knows? So that's not a very good answer, I realize, but it's the best I can do. There's also a question about curious if Blues can be used with old hardware, and I'm just going to throw out a very generic response. If you can communicate over I2C or serial, then yes. With an asterisk on there, I'm sure there's probably some exceptions that I'm not thinking of, but yeah.
I have seen also a question about HMIs, just to answer about in Opta's side. Basically, we spoke about the standard protocol for communication, and we are supporting Modbus TCP communication, which is one of the mostly common protocols used to communicate with HMIs. So we have several, let's say, cases of connection between HMIs and Opta, but theoretically any HMI speaking Modbus is fine. And
There was a
maybe
question about, sorry.
oh.
There's a
Go
question about the voltage that was coming through in the emails. That was the voltage of the capacitor. So that's like a pass through to the reason I was sending it for the demo is you might want to keep track of whether that capacitor is going to run out. And so it's just passing it through.
And what I wanted to say before is just related to the cases of connectivity with other type of PLCs. A case, which I did not mention in my slide, but is very, very common, is customers asking to retrofit existing machinery. This is related to the fact that up to a certain time, all of these devices managing the business logic in the industry were not connected. So one other case that we can implement for sure is to basically act as a gateway between an existing system and the network. So also, let's say, revamping an existing setup, and that, of course, saves a lot of costs.
With that, I want to be cognizant of everybody's time here. Thanks again to everybody who attended. I will be sending out a follow-up email with a link to the recording. Absolutely feel free to reply to that email with any questions you have, and I can forward that email or answer your question for anybody on the panel here. But we'll provide links to additional resources for you all as well. So thanks again, and we'll see you next time.
Yeah. Thanks, everybody.
Thanks.
Bye, guys. Bye.